All right, we're going to do section 2.2, and it is called betweenness. And I'm going to give you a definition of between. And if you go up to the next chapter, we'll see another definition of between. But there's a few things we have to learn before we can use it. So far, we're only able to use what we've learned, which is the things from last section are the rays and the intersection, stuff like that. So this is the definition that you're going to see in your book. So here's a picture. You have your line A, B, and C. So it definitely looks like B is in between A and C. This is the definition that you would have to use though. B is between A and C if it says ray BC intersected with ray BA equals point B. So let's just take a look at that. We have ray BC is this one, right? And it says ray BA. So they're both including the endpoints. Now when you're taking the intersection of them, you could see that you're looking for what's in common. Definitely B is what they have in common. So that's what makes this a true statement. Now let's just take the same picture and just come up with, a false one, and we'll see how it doesn't work with our picture. It says if C was between A and B, which we know it's not, but if it was, let's put all these things into our definition pattern and see if it works. If C was in between A and B, then you would say ray CB and ray CA's intersection would be C. Now let's just take a look at ray CB is this one. Okay, ray CA is this one. All right, when you take their intersection, do you just get point C? No, they have like every single point in common. So it doesn't work. If you ever come up with trying to intersect the two rays and their endpoint isn't what is in common, then you don't have that point being the one in between the two others. So it sounds a little complicated. Hopefully you just kind of get an idea of what that picture's saying, because you don't have to use it like that all the time. So there's an example at the top of page 46 that is pretty much this one right here that we just went over. So a couple more definitions that we're going to talk about. We're still talking about subsets of lines, basically. So we have opposite rays, or something else we're going to learn. All right, opposite rays, I think, are self-explanatory. Okay, if you take a look up here, if one ray is going that direction and one ray is going that direction, then you have opposite rays. The book, though, it says that you have opposite rays if and only if B is between A and C. So B has to be between A and C. You don't want any overlapping, so you wouldn't want these two right here would not be called opposite rays. They have to have the same endpoint. And then you could say those two are opposite rays. Another definition that we have is a segment. And a segment, it says, is a set consisting of 2 points, A and B, and all the points in between. So let's go with a line. Okay, we're talking about a subset of a line or a part of a line. So here we have A and B. So if you're talking about a segment, you need 2 endpoints plus the points in between. So what I'm going to do is I'm just going to raise it up. This is segment AB right here. You can spot it right here, but just to bring it up so you can see what it looks like. It's point A, it's point B, but it's all the points that are in between there. And in notation wise, this is what it's going to look like. AB with a line over it. No arrows. Okay, I've seen people do this. You do not have to do that. but I won't mark it wrong because I do know what you mean by that. So anyhow, that's segment AB. One of the things that it does mention is something called a vector. And a vector looks like a ray. Okay. But it would end up looking like this. Okay, that is different. We're not going to talk a whole lot about vectors, but vectors are rays with a specific direction. So we might, I don't think we do that anytime soon, but it looks like a ray. You just have to be able to take a look at your notation and notice that it's missing this little part right here. That makes all the difference in the world when it comes to notation. So there is a blue box that you have on page 46. You're going to have to make sure that you're getting, let's see, all of these right here. So you have point A, whoops, let's see, we have, all right, point A, you're going to have line AB notation, half line XY notation, array CD notation, segment AC, and then they have a vector LM here. So just go ahead and put in the correct notation for those down there. Easy enough. And the rest of the ones that you're going to have, ask me if you need help, but intersection and union, if you can keep going back to those and just keep asking yourself what's in common or what do I get when I put them together. We have done this a little bit in Algebra 1, but let me just give you maybe an example of what you could get here. If you have a line and you have A, B, and C, if they ask you to take segment AB and union it with BC, what would you get? So you'd come to your picture and you'd say, all right, this segment here, and I'm going to union it with this segment right here. It ends up just looking like you made a larger segment. So I would say you get segment AC. That's an idea of how you would use your pictures, your symbols, and your concepts of like the union and intersection for that. So 2.2, we are going to go with, let's go with 1 through 29 all. And that's your assignment.